Hello and welcome. This research project represents an open-world immersive and intelligent museum located on a virtual environment, and is implemented with the use of immersive technologies and artificial intelligence tools and techniques. The main goal of this project is to create a blueprint of an immersive virtual museum that supports cultural heritage and enhance the experience of the users with the use of game-like artificial intelligence algorithms and techniques into non-player character agents that are used as guides. For instance, this project can be used to present inaccessible cultural heritage, like castles, and help elder people to visit those places, with the use of immersive technologies, and at the same time the users will have smart agent to help them and present the different artifacts. For the implementation of this project we followed a different approach in terms of AI than the traditional fitting of data to machine learning and/or deep learning models. In particular, the techniques that have been implemented and used are natural language processing with speech synthesis and speech recognition, machine learning, and knowledge-based chatbots, pathfinding algorithms, finite state machines, blackboard models, behavior trees, decision trees, and grid-oriented planning. In particular, pathfinding and natural language with speech synthesis and speech recognition have been used in the implementation of an intelligent agent that the users can have a conversation with and navigate them to selected statues, as can be seen in the video.
Hi.
Hello.
Can you take me to the first statue?
Follow me, please. Another combination of artificial intelligence techniques that have been used is the combination of finite state machines and natural language processing. Those techniques have been used to create a simulation of a tour, where a non-player character agent is presenting to a group of visitors, including the user, the statues that have been created with photogrammetry. Hello and welcome to our quick tour. All statues can be found in the island of Cyprus and have been imported into this museum using photogrammetry. The first statue is Yuri Alexeyevich Gagarin, and it is located in Nicosia. Here we can see the Waves sculpture statue. This sculpture is located in the Open Sculpture Museum of ACIR Napa. Next up we can see the Argonaut statue that is located in the Open Sculpture Museum in ACIR Napa, and it's created by Aphrodite Sartampakoubi. The concept of that sculpture is to capture the purity and beauty of the Greek land. Another combination of artificial intelligence techniques that have been used is the combination of behavior trees with grid-oriented planning and the blackboard model. In particular, blackboard model is used to collect the information by the different selectors, which are collecting data based on the actions of the user. For example, the time that the user spends in front of a statue, which statues have not visited yet, and finally if the user has taken the tour from the other agent. Then that information is retrieved from a non-player character agent, and depending on the data, the behavior tree is activated and the agent changes its behavior. For instance, in case that the user has spent more time in front of a statue than the rest of the statues, then the agent approach the user and ask him if more information about that statue should be presented. Similar to that, the same applies for the rest of the examples. In case that the user didn't visit a statue, then the agent informs the user that this particular statue has not been visited. The same applies to the last behavior, which checks whether the user has taken the tour. In case that the user did not take the tour, then the agent approach the player and ask him if he wants to send the user to the tour. The last combination of algorithms that is implemented is the combination of decision trees, blackboard model, and grid-oriented planning. In particular, blackboard model is used to collect data by the different selectors that are specifying which areas of the terrain or the grid have been visited. Then, those data are written inside the blackboard, and an arbiter class collect those data and apply them on a decision tree to make the decision. Based on that decision, the appropriate agent out of the 4 currently available agents approached the user and gave him information about the unvisited areas. The tools that have been used for the implementation of this open-world IR game-like application vary depending on the purpose. For the environment design and code-wise implementation of most AI techniques, Unity Game Engine, C# and GitHub have been used. In addition, for the implementation of NLP and pathfinding in the application, Azure Cognitive Services and Unity's NavMesh features have been used. In addition, as we plan to make the IR application in the form of a mobile application that can be used with Google's cardboard-based head-mounted displays, we use the Android SDK and Google VR technology. This project introduces a variety of game-like AI techniques and AI concepts to implement intelligent and reasonable behaviors on NPCs in a multi-agent environment. This implementation contributes to the IR domain, as it presents that the merge of immersive technologies with concepts of artificial intelligence can create results that are improving the experience of the users and at the same time, give a serious reason to people that have no interest in museums to access them and enjoy their experience, while learning important information about the particular museum's concept. Even though this video comes to an end, the potential for further work is unlimited. We are planning to integrate more intelligent and humane agent behavior through reinforcement learning. Finally, with the use of data analytics, we will gain various insights to improve the overall user experience even more. Thank you so much for your attention.